Find the arc length. For the function, for the curve that is described in the parametric form equations. So when t is changing from 0 to 1, that's my domain, x is running as a quadratic function from 0 to 1. And then y is running as a cubic function. That's how cool it is. Each input and output are functions. Your job is to remember the formula. The formula is L equals integral from a to b, a huge square root. Each derivative, start with any, doesn't matter, squared, and another derivative squared. The order doesn't matter, and you're adding them. And also signs don't matter, whatever, because it's squared anyways. Equals integral from 0 to 1, right away, nothing too complicated here. Derivative of any function. Who wants to tell me everything? Just tell me everything. 2t squared, that is derivative of t squared plus 1, plus t to the 4 over 4. 3t squared, good job. 3t squared, squared, thank you. dt, good job. Did you catch the mistake? Don't integrate, we differentiate. I know the brain gets confused when we do both at the same time. So if I just ask you to choose the formula from the list, that is the answer. If I do ask you to integrate, which is probably not going to happen, we already practiced integration in 2 exams. So it's on the final exam, we will ask you to do integration by parts one more time. But for the 3rd exam, that's not the goal. So that's why I just very open about this. But you do simplify 9t to the 4, and then you figure out how to integrate it. In this case, you actually factored out, blah, blah, blah. Sometimes you need integration by parts. Sometimes you need to plug in secant, and it makes it better. Sometimes you fail, and you do numerical integration, maybe Simpson's rule, and so on. So I have solutions of this problem in my key for the review exam. But if we just ask you to choose the formula, then the box is the answer. Nothing to overthink here. Does it make sense? Can you do that on the test? Very good.
What formula is that again? With the square root?
That is the arc length formula. Thank you for asking. Let me sign it. Arc length formula. One more arc length formula. The previous formula we had was from a to b, a huge square root 1 plus or minus, plus derivative squared. And it was either dy or dx, depending on the function. Now we have 2 derivatives of x and of y, so it makes sense to mention them both. And you add. So it used to be this formula, L equals. Now we're using formula for the parametric equations.
So it's a parametric.